Let us verify Rolle's theorem for fx equal to x into x minus 2 whole thing cube, x lie on the interval 0, 2. We have a function fx equal to x into x minus 2 whole thing cube on the interval on 0, 2. If we want to apply Rolle's theorem, we need a function to be continuous. F being a polynomial function, first point, f being a polynomial function is continuous. We know that all the polynomial functions are continuous. In particular, f has to be a continuous function. Second point, your end point 0 and 2. f0 equal to 0 into 0 minus 2 whole thing cube equal to 0, and f of 2. Remember, we need to check the value of function at the end point 0 and 2. Whatever be your end point or the interval, whatever be the beginning and ending of the interval, we have to check at those points that function value of the function. So, f0 equal to 0, f of 2 equal to 2 into 2 minus 2 whole thing cube, that is again 0. Therefore, f0 equal to f of 2. So, those two values are equal. Next, we need the function to be continuous. We got it to be a polynomial, so it is continuous. At the end point, the value of function are equal. Third point, f is differentiable on the open interval 0, 2. Again, f is a polynomial we know that polynomials are always differentiable throughout R, in particular, so differentiable on open interval 0, 2. So, Rolle's theorem is applicable by Rolle's theorem there exists a constant C. By Rolle's theorem, there exists a constant C such that f dash of C equal to 0 and C belongs to 0, 2, sorry, open interval 0, 2. That is, that constant C must be greater than 0, less than 2. That must happen. By Rolle's theorem, we are guaranteed that f dash C must be equal to 0 and that C must be between 0 and 2. Now, Let us find f dash x. Fx equal to x into x minus 2 whole thing cube. Therefore, we can find f dash x. We can apply product rule of derivative. First function into derivative of second, x minus 2 whole thing cube. If you differentiate, you will get 3 into x minus 2 whole thing square plus derivative of first function, derivative of x is just 1 into x minus 2 whole thing cube equal to, we can take x minus 2 common, or rather x minus 2 whole thing square common. When we take x minus 2 whole thing square common, we are left out with 3x plus x minus 2. That is equal to 4x minus 2. Now, Roche theorem says there exists a constant c such that f dash c equal to 0. Roche theorem guarantees that there has to be a constant c so that f dash c equal to 0. Now, f dash c, we need to pick up such a constant, f dash c equal to 0 if c minus 2 whole thing square whole thing into 4 into c minus 2 equal to 0. That forces us to take c equal to 2, but we cannot take so. So, 4c minus 2 equal to 0, there we have c equal to half, and half lie on the interval 0 comma 2. So, we have found a constant c such that f dash c equal to 0. In other words, f dash of half equal to 0, and we have exactly verified Roche theorem for this particular function. F dash half equal to 0 and half lie on the interval 0 comma 2. So, we have verified Roche theorem.